A lot about climate change is looking into the past and climate data, and we want to dig into some of that long range climate data. Joining me now is Renie, a research meteorologist with NOAA's National Centers for Environmental Information. Jared, welcome, and tell me a little bit about what your job is.
Well, thank you for having me. My job is playing with a bunch of data. So I work for NOAA's NCEI, and we archive all the world's weather and climate data. And it's basically just a sandbox for us to go in and kind of play with the data, come up with cool graphics, do some interesting climate change research, and just come up with a story to talk to the public about our data.
And I want to get right into it. You work with a lot of data. So I've kind of asked you, what are your top three-ish data sets that really stand out to you, and also kind of dig into a local perspective here in Michiana?
Yeah, so the first data set, I'm going to share my screen here. The first data set is called GHCN. Now, we love our acronyms. So GHCN stands for the Global Historical Climatology Network. And it's basically a bunch of weather stations across the US and globally. We have over 100,000 of these in our database. And depending on where the station is, we have data that goes far back, hundreds of years. I think in Europe, we have data that goes back to the 1700s. But for this particular station here in South Bend, we have data that goes back to 1893. Now, what you're seeing is one variable. We record all these different types of variables like temperature, precipitation, snowfall, wind speed. In some cases, we have solar radiation, soil moisture. This particular one is for precipitation. So what you're seeing is sort of an accumulation of precipitation over time for 1 year, which is the black line, which is 2023. And it's kind of it's a race through time to see where it's going against all of the other years in its record. And they're colorized by how wet or how dry a certain year is. And then what I also want you to see is sort of this yellow line, which is what we call our normal. So we create 30-year normals that tell you, if you're warmer or colder or wetter or drier than what you perceive to be. So that yellow line is what we call the normal. Now, 2023 was really interesting. So, looking at the black line, it kind of starts out kind of following that yellow line where it's starting, you're getting some rain. It's just as it's expected. But then springtime happened last year, and then there was a lot more rain than what you expected. So now the black line is sort of above the yellow line. And then as you get into the summer months, maybe it was a little drier in your area. You didn't have much rain, so you kind of fell back into the yellow line where, maybe it's sort of drought conditions in that area. But then at the end of the summer, things kind of picked up where you had some more rainfall. And then in the end, you ended up with about 40 inches of rain, which is just about what you expect for that given year. And what I like about this is that you can look across all the other years. You can see what your wettest year on record was in 1990, where you had 55 inches. But you can also see the driest year on record, which happened in 1917. So I really like this data set because it's one graphic, but you're looking at hundreds of years of data here.
And what I like about that, it really exemplifies last year, which we did have drought conditions in the month of June, and then we rapidly overcame those drought conditions in the month of July. And this is something I've seen in recent years, which is we have a month of flash drought, and then we seem to get all our rainfall at once, and yet it still averages out to normal precipitation for a year, but we've experienced both extremes.
Right. Yeah, and it depends on where you are too. There's some areas that had a lot of rain. I think in Florida there was one area that had Fort Lauderdale. They had insane precipitation in a couple of days, and they had their wettest year on record. But just 30 miles away, west of Fort Lauderdale, there was a station that had their driest year on record. So it's really interesting to see all these cool things.
All right, I want to keep moving along. I know you have more data sets here, even talk about some snowfall and temperatures and where we have gone with that.
Right. So the next data set I want to share with you is snowfall, which can be a fun topic to talk about. We have data here at NOAA that goes back to 2008 that sort of animates how much snow is accumulated over time. And what you're seeing here is what we like to call an anomaly or a difference. So I had mentioned earlier that we had a climatology of about 30 years. Here it's about a 14-year climatology, and from 2008 to 2022. And this is sort of the winter season that has occurred so far. So this started in October of 2023, and that kind of goes up to early February of this year. And a lot of cool features over time. You can see some areas started to get a lot of snow to kick off, especially in New England, up in the Midwest. But then all of a sudden, you see a little bit of brown. The brown indicates that you're sort of lower than what you're expected. And especially in the Michiana area, I'll kind of point that area here. Didn't get some snow. You started a little bit above normal at first, but then kind of really dried out as the days went on. And right now you are about a few inches below what's expected. But I think, as we all know, all it takes is one storm to sort of change that perspective.
Yeah, and we're known for lake effect snow here as well. A question I'll give to you is, why does it only go back to 2008? A lot of people are like, well, what about the blizzard of 78? Why isn't that in this kind of data set?
Right. I'm originally from New England, so I very much know about the blizzard of 78. One of the reasons is because of the observations, because so we use our in situ point networks to kind of build this data set, and we also use satellite data. That's the other big thing. And satellite data can only go far so back. So when we do point stations, we can go back farther than 2008, but because of the data that goes into this model, that's why we only go back to 2008.
Gotcha. And part of it is really, what have you done for me lately? Is, like to say, with some of this climate data, is a lot of this change really has been since the year 2000 or so, that we're seeing a bigger difference of, well, what was once winter isn't so wintry.
Right, that's correct. It takes, some years, you can still have really high winter seasons. I know in New England, about 10 years ago was a big winter season for them and for certain parts of the Midwest. But yeah, when you look at the changes over time, it's starting to decrease a little bit.
And you have, I believe, a chart about South Bend snowfall over time. Do you want to go to that one next?
Yeah, hold on one second.
But I found a lot of this information really interesting because, again, how far back you can go and you can compare these normals over time, which a lot of people don't really think about. And some of these normals are changing over time as well, because we're in 30-year increments. So this is South Bend snowfall all time. Is that correct?
That's correct, going back to the late 1800s. So, and looking at this black line again, compared to all the other years, I mean, you're clearly in a snow drought. You had a few events at the beginning of the year, but it's been pretty much flatline since, and you're well below normal. And again, it takes one or two snowfall events to sort of change that, but you need a lot of catching up to do.
Yeah, we had basically a week of winter, and it doesn't look like in the near future that we're going to overcome this. And I want a lot of people to notice out that there are a lot of lines in there, and I can tell you that most of those lines are most likely of recent years, which we saw in some of that map data as well, kind of staying below that normal area, which is that the dark blue line, which is normal?
Yes, the dark blue line here is the normal, which is calculated between 1991 and 2020.
And so you kind of see that fine demarcation right there, and more of our years seem to be coming on the underside of that line than the overside of that line. Yes, we can have some big storms, but it seems like now year after year after year we come in on that under. I want to get to a couple more of those data sets that you wanted to talk about. There's one that was on temperature and annual temperatures. Even 2023 I thought was really interesting, of the highs and lows in the temperature range. Yeah, I found this chart really interesting. Can you kind of explain what this is?
Yeah, so it's a little bit different than the other ones you saw, in that you're still looking at multiple years of data, but you're really focusing on 1 year. So this is for 2023, and what the red line is your daytime maximum temperatures, and the blue line are your overnight temperatures, and you're comparing against two different things. You still have that normal period, so 1991 to 2020. That's sort of the shaded, smooth area, and then the other one, sort of the other gray brownish variable, that's sort of the extremes. So that's the hottest day that ever recorded on that particular day. So you kind of see a couple things here. So especially looking at the early part of the year, it looked like you had a cold snap at the end of January going into February, but then it warmed up a little bit above normal for parts of March and May, and your summer looked like it was really warm. And then as you get to the end of the year, you notice that there's sort of these dots on here, and that indicates records were sort of tied or broken. So you had a daytime record that was beaten in the middle of October. But what's also interesting is that you had these nighttime temperatures beat the record. And that's sort of consistent with what we're saying, is that we're seeing more minimum temperature increases than we are with maximum. So you have in your ratio here, you had 3 minimum temperature records since August, but you only had 1 maximum temperature.
And another thing that stands out to me on this graph is there's no record lows that were set. And is that something that you see with all the data sets you work with, that when you look at all the records that are being set, what's the weight here to record or warmth records versus cold records?
Yeah, so there are regional components of this. Parts of the upper Midwest, like Montana and the Dakotas, they actually saw a lot of cold records last year. But when you look at the whole nation and even globally, the sort of that ratio, we are seeing way more maximum minimum temperatures being broken on the high level than we are on the cold.
What I also like about this chart is, maybe we can explain it to people who are not as science minded, but this kind of shows that shift in climate where the highs are just staying a little bit higher overall along that bell curve, and so are the lows, versus spending more time on the below average side. Does this chart kind of show that?
Yeah, that you're absolutely right. You have to look in certain spots, you have to kind of compare it against that sort of that smooth data. But yeah, there are a lot of, not all days, but a good chunk of those days are above what is expected. And that, again, that's consistent with the rising temperatures and climate change.
And if this trend were to continue in 20, 30, 40 more years, even that average mark, is that continuing to shift, or is this an all-time climate average going back to 1950 or prior?
Yeah, so this average is from 1991 to 2020. We usually update this every 10 years. So in our last update, we did notice a lot of places had sort of an uptick in all of their curves as a result of recent warming.
Very interesting. Again, this is kind of demonstrating that shift we're seeing in the climate. Some of it's a little subtle. It's not every single day, but overall, year after year, we are seeing warming to be more likely than cooling.
That's correct.
Are there any other data sets that you wanted to share or you thought that stood out?
So I have one more. So a lot of the graphics that we've showed, they have a lot of different axes and numbers and lines and, and even the maps, you see certain regional patterns and you kind of have to stare at it for a little while to come up with a trend. But there's a gentleman, he was from the University of Reading. His name was Ed Hawkins. He came up with something called the climate stripe, which I think is a really stark, really noticeable, really minimalistic way of seeing the same data, but kind of talking more about climate rather than weather. So let me just share my screen here. So this is actually the temperature climate stripe for St. Joseph County, Indiana, where South Bend is located. And there's some text in here, but I could remove the text and you can really see one thing is that there's more red on the right-hand side of the graphic than there is blue. And that's sort of the signal of climate change. Now, some of you may be thinking, well, there is some blue in here, and that's true. We can still have cold events. We can still have cool years. We can still have, really cold days or snowy days. But the trend is that the sort of the shifting from the blues on the left side to the reds on the right is pretty stark. And if I showed you a global version of this, it's even more stark than this.
It's a great way to exemplify that. In fact, our graphics here for sudden shift also use that same similar data set of those climate stripes because it does stand out immensely. I'll come back to you, and you work with a lot of this data. And what's your biggest takeaway from all the data sets that you work with about a sense of urgency as far as how quickly this change is happening?
It's certainly concerning. It's unprecedented. We have not seen shifts like this. We have data that goes back thousands and thousands of years as well, and we haven't seen a shift this quickly. And when I mean shift, I'm talking about two things. I'm talking about extreme temperatures and I'm talking about extreme precipitation. And looking ahead to the rest of the centuries, that temperatures are going to continue to go up, and extreme precipitation days above 3 inches, are going to be going up as well.
You can stop your screen share, and I just want to ask you one more question. Is it too late, or can we use this information to act?
I think the information, no, it's not too late, but it's important to have this information to kind of convey the story to the public, is that, climate change it can be different for different people. You know, some areas might be more affected by temperature extremes, but then some other areas may be more affected by severe drought or severe rain or flooding, or severe weather. So it's important to, with the data that we have, is to sort of localize it to the constituents and say, here is your climate story. You may not be affected by sea level rise, but you are going to be affected by more flooding. You may not be affected by temperatures, but you might be you might have more issues with drought. So it's really important to really convey that story to show that it's not too late. And there is legislation out there like the Bipartisan Infrastructure Law and the Inflation Reduction Act that is geared towards sort of helping us become more resilient to these types of events.
I really appreciate you sharing and taking some exclusive data sets just on our area to kind of dig into some of the data that we often see on a national scale. Meteorologist Renie with the NOAA's National Centers for Environmental Information. Thank you for joining us.
Thank you for having me.